We have that a stone is thrown off of a 100-meter cliff. They tell us the height of the stone can be modeled by this quadratic equation, where h of t represents the height of the stone t seconds after it was released. So we're first being asked to figure out at what time the stone will be at its maximum height. So I'm going to first draw a picture to give us an idea of what this looks like. For the picture, the first thing I notice is that I need to make a correction to this. This should be a negative 4.9 t squared in the front. And I know that it has to be negative because as I go to draw the picture, let's say that this is the cliff right here. Let's say this is the cliff. This is the 100-meter cliff. So someone's up here throwing a stone. When they throw the stone's going to do this, and eventually it will fall. But just from looking at that, we can see that this parabola does open downwards. And so A has to be negative. A has to be less than 0, which is how I know that I must need that 4.9 that's in the front of the t squared to be a negative number. Okay, so now that we have that fixed, the first thing we're being asked to find is the time at which the stone will reach its maximum height. The stone reaching its maximum height will occur at the vertex. A lot of the times when you're dealing with these quadratic word problems, they're asking for the maximum of something or the minimum of something. That's always going to be happening at the vertex. So this vertex has some x coordinate that I'm calling t, since t is our independent variable here, where it reaches its max height. And then it also has some y coordinate, which I'm just going to call h because it represents height. So in part A of this problem, they are asking us for the x-coordinate of the vertex. The vertex formula, we know that the x-coordinate of the vertex is equal to negative b divided by 2a. So we can just plug in here. B is the number that's in front of x, or in our case, the number that's in front of t, which for us is a 10. So I'm going to be plugging in a 10 in the numerator. And then a is the number that's in front of x squared, or in our case, the number that's in front of t squared, which for us is a negative 4.9. So in my calculator, I'm going to take negative 10 and I'm going to divide it by 2 times negative 4.9. And that gives me out, rounding to 2 decimal places, about 1.02. And this is in seconds, because they do tell me that t is measured in seconds. So now we do know the x-coordinate of the vertex. We've figured out when the stone is going to reach its maximum height. Part B of this question is asking us for what is the maximum height. Well, we know when the maximum height happens. What the maximum height is what the y-coordinate is at the vertex. So part B of this question is asking us for the y-coordinate of the vertex. And once we have the x-coordinate of the vertex, we can very quickly find the y-coordinate of the vertex by taking our answer from the x-coordinate and plugging it into the function. So I started to write f, but I erased it because our function's name is h here. So inside of h, we're going to plug in the x-coordinate from the vertex, which is the 1.02. So we have negative 4.9 multiplied by 1.02 squared plus 10 multiplied by 1.02, and then to that we are going to be adding 100. So I'm going to go ahead and punch this into my calculator, and when we punch this into our calculator, what we will get out is what the maximum height of the stone is, which I get about 105, rounding to the nearest meter, meters. The last part of this example is asking us when the stone will hit the ground. The stone will hit the ground, so I'm going to continue on in this picture, because keep in mind here, if we have this 100-meter cliff, if it's a 100-meter cliff, it means that it's 100 meters off the ground. So there's the ground there. So the stone will not hit the ground until right here. So what's happening here is when the stone hits the ground, the height of the stone is 0 because it is not in the air, it is actually on the ground. So to figure out when the stone will hit the ground, I need to set the height function equal to 0 and solve that equation. So I'm going to set negative 4.9 t squared plus 10t plus 100 equal to 0. And to solve this equation, I'm not going to complete the square. I'm not going to try to factor this. I'm just going to go ahead and use the quadratic formula. So I'm going to go ahead and get the quadratic formula set up. The quadratic formula says t is equal to negative b, which would be a negative 10, plus or minus the square root of b squared, 10 squared, minus 4 times a, which is a negative 4.9, times c, which is 100. And then all of this is divided by 2a. So all of this is divided by 2 times a negative 4.9. I'm going to go ahead and see what that number is under the square root. So I have 10 squared minus 4 times negative 4.9 times 100, which gives me that the number under the square root is 2060. So we have negative 10 plus the square root of 2060, all divided by, in the denominator, 2 times negative 4.9 is a negative 4.8. No, excuse me, a negative 9.8. So I'm going to go ahead and separate this into two separate answers here. There's a negative 10 plus the square root of 2060 over negative 9.8. And then there's a negative 10 minus the square root of 2060 over a negative 9.8. So I'm going to evaluate both of these. If we take the square root of 2060, that's not a perfect square. So negative 10 plus the square root of 2060 divided by a negative 9.8 comes out to be approximately negative 3.6. And then if I take negative 10 and I subtract the square root of 2060, and then I divide all of that by a negative 9.8, that gives me about a positive 5.65. Now remember that we are looking for when the stone will hit the ground, at the time the stone hits the ground, so our answer can certainly not be negative, since our answer is going to be in seconds time. So our answer is the stone will hit the ground at about 5.65 seconds.